question concerns the correct ampacity adjustment factor for an insulation of 7 non-jacketed 12 American wire gauge type metal-clad cables, each with 3 current-carrying conductors bundled together longer than 24 inches. The task is to determine the appropriate adjustment factor to apply to the ampacity of the conductors. The National Electrical Code, or NEC, addresses this situation in 310.15b2. This section provides guidance on adjusting ampacity when multiple current-carrying conductors are bundled together. The specific part of the code relevant to the question is 310.15b2, which deals with adjustment factors for more than 3 current-carrying conductors in a raceway or cable or earth or aerial cable. When the number of current-carrying conductors exceeds 3, the ampacity of each conductor must be reduced. The amount of reduction is determined by the number of conductors. The key to answering the question lies in understanding how to apply the adjustment factors provided in the NEC. In this scenario, there are 7 metal-clad cables, each containing 3 current-carrying conductors, resulting in a total of 21 current-carrying conductors. This number exceeds the threshold that triggers the need for ampacity adjustment. The NEC specifies different adjustment factors based on the number of current-carrying conductors. For example, if there are 4 to 6 current-carrying conductors, the adjustment factor is 80%. For 7 to 9 current-carrying conductors, the adjustment factor is 70%. And for 10 to 20 current-carrying conductors, the adjustment factor is 50%. However, when the number of current-carrying conductors exceeds 20, a different rule applies. According to 310.15b2, for a non-jacketed multi-conductor cable with more than 20 current-carrying conductors bundled in a flat configuration, an adjustment factor of 60% must be applied to the ampacity of each conductor. This means that the allowable ampacity of each conductor is reduced to 60% of its original value. The question presents a scenario where the total number of current-carrying conductors is 21, which is greater than 20. Therefore, the correct adjustment factor to apply is 60%. The reasoning behind this adjustment is to account for the increased heat generated when multiple current-carrying conductors are bundled together. When conductors are bundled, they are less able to dissipate heat, which can lead to overheating and potentially damage to the insulation. By reducing the ampacity of each conductor, the amount of heat generated is also reduced, preventing overheating. It is important to note that the adjustment factors provided in the NEC are based on specific conditions such as the type of cable, the ambient temperature, and the method of installation. In some cases, it may be necessary to apply additional adjustment factors to account for these conditions. For example, if the ambient temperature is higher than the temperature rating of the conductor, the ampacity must be further reduced. Similarly, if the cable is installed in a location where it is exposed to direct sunlight, the ampacity may need to be reduced to account for the additional heat. In a given scenario, the question specifies that the cables are bundled together longer than 24 inches. This is an important detail because the adjustment factors only apply to bundled conductors. If the cables were not bundled, the adjustment factors would not apply. The length of the bundle is also a factor. The longer the bundle, the greater the heat buildup and the more significant the ampacity reduction. Therefore, it is important to carefully consider the installation conditions when determining the appropriate ampacity adjustment factor. The NEC provides guidance on how to select the appropriate adjustment factors based on the specific conditions of the installation. In addition to the adjustment factors provided in 310.15b2, the NEC also includes tables that provide the allowable ampacities of conductors based on their size, type, and temperature rating. These tables can be used to determine the original ampacity of the conductor before applying any adjustment factors. Once the original ampacity is determined, the appropriate adjustment factor can be applied to calculate the adjusted ampacity. The adjusted ampacity is the maximum amount of current that the conductor can safely carry under the given conditions. It is important to ensure that the adjusted ampacity is not exceeded, as this could lead to overheating and potentially damage to the insulation. In summary, when dealing with multiple current-carrying conductors bundled together, it is essential to apply the appropriate ampacity adjustment factors to ensure the safety and reliability of the electrical installation. The NEC provides guidance on how to select the appropriate adjustment factors based on the specific conditions of the installation. In a given scenario, where there are 21 current-carrying conductors bundled together, the correct adjustment factor to apply is 60%. This adjustment factor reduces the allowable ampacity of each conductor to 60% of its original value, preventing overheating and ensuring the safe operation of the electrical system. So the answer to the test question: an installation consisting of 7 non-jacketed 12 American wire gauge type metal clav cables, each with 3 current-carrying conductors bundled together longer than 24 inches, shall have an adjustment factor of 60%. It is important to understand that the adjustment factors provided in the NEC are based on specific conditions such as the type of cable, the ambient temperature, and the method of installation. In some cases, it may be necessary to apply additional adjustment factors to account for these conditions. For example, if the ambient temperature is higher than the temperature rating of the conductor, the ampacity must be further reduced. Similarly, if the cable is installed in a location where it is exposed to direct sunlight, the ampacity may need to be reduced to account for the additional heat. The National Electrical Code also specifies the methods for calculating the ampacity of conductors under various conditions. These methods take into account factors such as the conductor size, insulation type, ambient temperature, and the presence of other heat sources. By following the guidelines provided in the NEC, electrical engineers and installers can ensure that electrical systems are designed and installed safely and reliably. In addition to ampacity adjustment factors, the NEC also addresses other aspects of electrical safety, such as grounding, bonding, overcurrent protection, and wiring methods. It is important to have a thorough understanding of these requirements to ensure the safety of people and property. Electrical codes are constantly evolving to reflect new technologies and safety concerns. It is important to stay up to date on the latest changes to the NEC to ensure that electrical installations are compliant and safe. This can be achieved by attending training courses, reading industry publications, and consulting with experienced electrical professionals. Proper installation and maintenance of electrical systems are essential for preventing electrical hazards such as shocks, fires, and equipment failures. Regular inspections and testing can help identify potential problems before they become serious. It is also important to use qualified electrical contractors who are familiar with the NEC and have the necessary skills and experience to perform electrical work safely and correctly. In summary, the correct answer is 60% adjustment factor according to NEC section 310.15 B2 when dealing with more than 20 current-carrying conductors bundled together. Remember to always consult the latest edition of the National Electrical Code and to seek guidance from qualified electrical professionals when designing or installing electrical systems. Safety should always be the top priority in any electrical work. Furthermore, it is important to consider the specific installation conditions when determining the appropriate ampacity adjustment factor. Factors such as ambient temperature, cable type, and the presence of other heat sources can all affect the ampacity of conductors. By carefully considering these factors and following the guidelines provided in the NEC, electrical engineers and installers can ensure that electrical systems are designed and installed safely and reliably. The NEC also provides information on the proper selection and installation of electrical equipment such as circuit breakers, fuses, and transformers. These devices play a critical role in protecting electrical systems from overloads and short circuits. It is important to select equipment that is properly rated for the application and to install it according to the manufacturer's instructions. In addition to the NEC, there are other standards and regulations that may apply to electrical installations. These include state and local codes, as well as industry standards such as those developed by the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. It is important to be familiar with all applicable codes and standards to ensure that electrical installations are compliant and safe. Continuing education is essential for electrical professionals to stay up to date on the latest technologies, codes, and standards. There are many opportunities for continuing education, such as seminars, workshops, and online courses. By investing in continuing education, electrical professionals can enhance their skills and knowledge and provide better service to their clients. Sir, for the situation involving the 7 non-jacketed 12 American wire-gauge metal-clad cables bundled for more than 24 inches, the 60% ampacity adjustment factor derived from the NEC 310.15 BTU is the correct application due to the conductor count exceeding 20. Also, to reiterate, remember to consult with the latest edition of the NEC and qualified professionals for electrical installations.